Now we will see speed time. Second graph is speed time graph when the speed changes at a uniform rate or uniform acceleration. Now this is the case that speed is increasing. This is the line, this is the curve. Speed is increasing with the gradual increase in time. So speed time graph for a uniformly changing speed. That means speed is changing. Initially the body was at rest. Now it has started accelerating from 0 to whatever be the speed, and it reached, let us suppose that it reached at point P. Now this is the graph. We will draw two perpendiculars, PQ and PR. Now we'll see. This is uniform acceleration. That means the speed is increasing. I have told you what is uniform acceleration in the last class. A body has a uniform acceleration if it travels in a straight line and its velocity increases by equal amounts in equal intervals of time. So it is increasing in equal amount as the time is increasing, equal amounts of time. Now here, initially the body was at rest, that is at point O, and then it gradually increases its speed. Acceleration is equal to, we know, change in speed or velocity. Here speed and velocity are the same because the body is moving in the straight line, divided by time taken. Now what is change in speed? Change in speed is OR. OR is equal to PQ, I think we can say, and the time is OQ. So acceleration is equal to PQ divided by OQ. The slope of speed time graph of a moving, we have already done that PQ divided by OQ, perpendicular upon base, is the slope. So here we can say that in a speed time graph, if we have to find out the acceleration, we can find out the slope. Next is distance. We can also find out the distance from the speed time graph. Earlier we have studied it was a rectangle, here it is a triangle. We have found out, we find out that what is distance? The distance traveled is the area under the curve. The area under the curve. So here it is not a rectangle, here it is a triangle. So area under the curve we can find out. We know the area under the curve, area of the triangle, OPQ, is half perpendicular into base. That means half OR into OQ, or you can write down half PQ into OQ. So we can also find out the distance traveled as well as the acceleration, if there is, the curve is like this. Next, if there is retardation, here we have seen that the speed of the body is increasing. Now suppose the speed of the body is decreasing. What will be the curve? The curve will be this. Initially there was some speed, and now the body has applied brakes. You may say the car, if suppose a car is traveling at 60 km/h initially at point B, and then it started retarding, and its speed decreases gradually with the time, and at a point it comes to rest. So this is the uniform retardation. This is the curve of uniform retardation. Next is, if the body has some initial speed and it is also increasing. Now this will be the curve. Speed time graph when the initial speed of the body is not 0. Now the speed is OB initially. When the time was 0, initially when the time was observed, the body was at this speed OB. Now it accelerated and reached to this point. Here the speed was AC. Now we will find out the distance. We know the distance is the area under the curve or area enclosed by the curve. Now here it is neither a triangle nor a rectangle. So it is a trapezium, or you may say this is a triangle as well as a plus a rectangle. We can find out either by summing the rectangle, area of rectangle, as well as the area of the triangle, or we can just see area of the trapezium. We have studied in mathematics, area of trapezium is sum of two parallel sides OB and AC into the height divided by 2. So here we can find out distance traveled is equal to OB plus AC into OA divided by 2.